Hello, welcome to another Research Methods for the Biosciences screencast for SPSS. This screencast covers Section 10 T and Z tests for unmatched data and includes Section 10.1 2-sample Z test, Section 10.2 2-sample students T-test and Section 10.3 2-sample unequal variance T-test. These tests are for when you want to assess if two samples are likely to come from the same statistical population or not. We often take samples from different situations and then when we compare the data from each sample, find it to vary. The question always is whether these differences are due to random variation or whether the unique qualities of each sample situation has created this difference. Take the data from Table 10.4. Here we have measured the height of periwinkle shoals from the lower and mid-shore and we find there is variation between these datasets. The question is, does the position of the periwinkle on the shore dictate to some extent how high a periwinkle shell will grow, or is the variation seen just due to non-perfect sampling, and if we could measure all the periwinkles on the shore, would we see no difference in the datasets? The null hypothesis would state that there is no difference between the mean shell height in millimeters of the periwinkles from the lower and mid-shore. The size of each sample is 13 individuals, and so we would use a t-test. Table 10.3 in the book, however, contains an enlarged dataset of 30 individuals per sample, and it is common practice to use a Z-test on datasets of 30 or more. However, when the sample size is more than 30, then the T and Z-test give very similar outcomes, and both can be used. And for this reason, most computer programs do not implement two-sample Z-tests as a simple menu selection. Thus, this screencast will only cover t-tests, and you should use the test for the larger sample sizes too. One further consideration we have to make is if the variances of the samples are similar or homogeneous, also termed homoscedastic, as there are different tests for when the variances are homogeneous compared when they are not. See Chapter 10 and Box 10.1 for more details. Fortunately, the computer program will also do this analysis for us too. So let's run the t-test. I have entered the shell heights from Table 10.4 into the column variable shell height. I have also created a location grouping variable called location with 1 indicating the lower shore and 2 the mid-shore. Using numbers for the grouping variable makes it easier later on, but is not particularly user-friendly. We can make the data more readable by assigning values to each number as follows. Track to variables and press the variable tab. This is how my variables are set up. To add values, I track up to the value cell in the location variable row and click. I now track down to value and click. I want to give a value to the number 1. In this case, the label will be lower shore. I press add to enter it. I'm now going to give a value to the number 2. Click in the label box. This is going to be called mid-shore. And again, I add. I now press OK. I can now go back to my data view. And you can see that now the location, instead of having numbers, are giving you the value names. To toggle between the numbers and the value names, you can use this split arrow button on the menu bar. Also, you can go to View and click Value Labels. So, let's run the t-test. We track up to Analyze and click, down to Compare Means, across to Independent Samples t-test on the submenu and click. A window opens. I now need to tell SPSS which variables to use. The test variable is the shell height. I select shell height and use the arrow to enter it in the test variable box. I now need to select the grouping variable, which is location, which I select, and enter it into the grouping variable box. I now need to define the groups so SPSS knows how to divide the data. I do that by clicking Define Groups. This is where numbers in the location variable saves me time. Sample 1 is the lower shore and denoted by the number 1. Sample 2 is the mid-shore and denoted by the number 2. I now press Continue and OK. The output gives us 2 boxes, and it is the second box that gives us our result. The first 2 result columns give the results for the Levene's F-test and give a probability of 0.109. So what is the meaning of the p-value? A p-value of 1 means we can accept the null hypothesis as true, whereas a p-value of 0 means we can accept the null hypothesis as untrue. As we travel from a p-value of 1 to 0, the transition point between true and untrue is set at 0.05 in the biological sciences. The smaller the p-value below 0.05, the more confident we can be in rejecting the null hypothesis. A value of 0.109 is above our transition value of 0.05, which means the result is not significant, and that we cannot reject the null hypothesis that states that there is no difference between the variance of periwinkle shells from the lower and mid shores. We can see from columns 3 to 5 that SPSS has performed a t-test for sample datasets with both equal and unequal variances. From the F-test result, we want the first number in column 5, which gives us a significance of 0.809, well above our 0.05 transition value, indicating a non-significant result and that we cannot reject the null hypothesis that there is no difference between the height of periwinkle shoals from the lower and mid shores at Porthcawl in 2002. I hope you found this screencast helpful. For further information on how to use this test, or the theory behind it, then please consult the book. More information on how to use the program to perform the test can be found in our online web guides located in the Resource Centre. Thank you for listening.